Hello friends, this is Priyanka. Today we are going to solve a problem on stability analysis and root locus technique. In this video, we are going to follow step-by-step procedure to draw root locus for open loop transfer function. So open loop transfer function g of s into h of s is equal to k s plus 1 divided by s plus 2, s plus 3, s plus 4. Now what is the first step? So whenever this open loop transfer function is given, we have to first find out the number of poles, that is n, and number of zeros. So we will first find out the number of poles. So for that we have to refer this denominator. So I will take this denominator, that is s plus 2 in second bracket s plus 3 and s plus 4, which is equal to 0. So we can say that s plus 2 is equal to 0, s plus 3 is equal to 0 and s plus 4 is equal to 0. So for the calculation of number of poles, we have to find out the roots from the denominator. So what is the value of s? So value of s is equal to, when s plus 2 is equal to 0, that is s is equal to minus 2. When s plus 3 is equal to 0, then s is equal to minus 3. And when s plus 4 is equal to 0, that is s is equal to minus 4. So we can say that the number of poles n is equal to 3. So I will write here number of poles n is equal to 3 because there are total 3 roots and poles lies on this minus 2, minus 3, minus 4. Now we will move for the calculation of number of zeros. So for number of zeros, that is m, we have to refer the numerator. So from the numerator we will select the s term. So s term is s plus 1. So we will equate it to 0. So s plus 1 is equal to 0 and therefore s is equal to minus 1. So there is only one root. So number of zeros, m is equal to 1. So we have to write here m is equal to 1. And root 0 will lie on this point minus 1. Now we will plot these poles and zeros. So for these poles I will use cross sign and for these zeros I will use this circle sign. So these signs that I will use to show in this S-plane. So how to plot the points? So for that we will first take real axis and imaginary axis. So real axis, that is the horizontal line. So we will show here the sigma. And we have to plot the points, and imaginary axis, that is this vertical line, and it is known as with symbol j omega. So on imaginary axis all the points we have to write in terms of j. So point of intersection of this real axis and imaginary axis is known as origin. So I will say O or 0. And then how to plot the point? So on the right hand side we have to take the positive sign, that is 1, 2, 3, 4 and so on. And on the left hand side on real axis we have to take the negative signs, that is minus 1, minus 2, minus 3, minus 4 and so on. Now we will move for the imaginary axis. So this point of origin, these above points, we have to take the plus sign and we have to write the values in terms of j because this is the imaginary axis. So how to write? So I will take here as a j, then 2j, 3j and so on. And in the same way below this point 0 we have to take the negative sign, that is minus j, minus 2j, minus 3j and so on. Now we have to plot the poles and zeros. So according to the signs I will plot here number of poles 3. I will show with this cross sign, and these poles lie at minus 2, minus 3, minus 4. So I will show with the help of cross, minus 2, minus 3, minus 4. And 0, number of zeros, that is there is only one 0 and it is at minus 1. So at minus 1 I have to show here as a 0. So that in this way we have to plot the poles and zeros on this S-plane. So this first step is getting completed. Now we know that number of branches. So whenever we are going to sketch the root locus we have to find the number of branches. So this number of branches is nothing but that is equal to number of poles n. So number of poles n, that is equal to 3, and that's why number of branches, that is also equal to 3. So this is important. Then we will move for the next step. Now what is the next step? So this number of branches are 3. So we know that these branches start from or originate from open loop poles and ends at open loop zeros. That is important. Branches start from open loop poles and ends at zeros. But what is happening in this question? There are total number of branches 3 and number of poles is also equal to 3. So branches start from these points -2, -3, -4, but ends at open loop zeros. But here number of 0 is only 1. So for this open loop 0, there is only one branch is getting completed or ends at this 0. But what about the other branches? That is important. So we can say that the branches originate from the open loop poles and ends at the open loop zeros, and the remaining branches terminate to infinity. So in this question we can say that one branch will start from open loop pole and ends at open loop 0, and the other two branches terminate to infinity. So we can say that branches originate from open loop poles and terminate to 0, that is equal to only one branch, and the other two branches terminate to infinity, that is two branches. Two branches will terminate to infinity and one branch will terminate to 0. So this is important. Now again we will move for the next step, or from this step we come to know that if I show here from this diagram, I can show the branch will start from this pole -2 and it will end at -1. So we have to show that. We have to show that is towards this 0. So this is the one branch that is getting completed. Now we will move for the next step. So what is the next step? Next step is we have to find out the range of points on this real axis for which total, or we can say sum of open loop poles and zeros is odd number. Now if we observe, odd number is nothing but number 1, number 3, number 5. Now what is the sum of here open loop poles and zeros? 1, 2, 3, 4. So here total sum of open loop poles and zeros is 4. That means odd number is 1, 3. Now if we have to find out the range of points, we have to take here, or we will try here trial and error method. Now I will show you how to take this point. Now for this total sum of poles and zeros is 4. So out of that odd number is 1 and 3. Now we have to find out the range of such a points for which to the right hand side there is total sum is poles and zeros is 1 or 3. Now if I take the point in between -1 and -2. Now any point in between -1 and -2 is having only one 0 to the right hand side. So this is the range in between -1 and -2, which is having odd number to the right hand side. So each point in between -1 and -2 is the part of root locus. Now we will move for the next. So I will write here a range, that is in between -1 and -2. So this is the one range. Now we will move for the next, that is -2 and -3. So if I take the -1, -2 and -3, any point in between this, then the total sum of poles and zeros. So here is one pole and one zero. So this is even number. That means we cannot take any point. So points in between -2 and -3 are not the part of root locus. Then we will move for the next, that is the points in between -3 and -4. So if I consider the points in between this -3 and -4, now on this right hand side there are total 1, 2, 3, that is 2 poles and 1 zero, that is 3 numbers are available, that is odd number is there. So we can say that the points in between -3 and -4 are the part of root locus. So we can say that this range is -3 and -4. So the points in between -3 and -4 are the part of root locus. Points in between -1 and -2 are the part of root locus. So here we have already shown branches, so we can easily show the branch that will originate from these poles and terminate at the 0, because all these points are the part of root locus. So this one branch is getting completed. So I will give here the number, that is this first branch is getting completed. Now we have to complete this remaining 2 branches which will terminate to infinity. So whenever there is one branch or more than one branch that will terminate to infinity, then what is the first step that we have to take? That is, we have to calculate the angle made by asymptote, and then we have to also calculate the centroid. So these 2 steps are important, and these steps we have to take only when there are the branches that will terminate to infinity. Now here there are 2 branches that will terminate to infinity. So first we will calculate the asymptote. Now what is this asymptote? Asymptotes are the line along which the branches terminate to infinity. So for that we have to find out the angle made by this asymptote with this real axis, and then we will calculate the centroid also. Now what is this centroid? Centroid is the point of intersection of asymptote on this real axis. Now first we are going to calculate the angle. So what is the formula? So formula is angle of asymptote phi A is equal to 2q plus 1 into 180 degree divided by n minus m. So n minus m, we know that 3 minus 1, that is 2. Now how to find out this value of q? So q value we have to start from 0, 1, 2 up to n minus m minus 1. So here n is equal to 3, m is equal to 1. So what is the value of n minus m minus 1? That is 3 minus 1 minus 1. That means here n minus m minus 1, that is only 1. So this value tends to 1. So we have to take q is equal to 0 and then 1. So we have to stop. So q is equal to 0, 1. So these 2 values we have to take here and we have to calculate the angle. So when I take q is equal to 0, then when q is equal to 0, then 180 divided by 3 minus 1, because n minus m is 2. So 180 divided by 2, that is 90 degree. So I will say that phi A is equal to 90 degree. And when I take q is equal to 1, so 2 into 1, that is 2 plus 1, 3, and 3 into 180 divided by 2. So when I take here, I will get 270 degree. So these are the angles made by asymptote with this real axis. But where to draw this asymptote? So we don't know from which point on the real axis we have to draw this asymptote at an angle of 90 degree and 270 degree. And for that, next step is to calculate the centroid. So centroid is nothing but we will take here the symbol sigma A. That is the point of intersection of asymptote on this real axis. So what is the formula? Formula is sum of real part of pole minus sum of real part of 0 divided by number of poles minus number of zeros. So we will understand this. So real part of pole. So for this real part of pole, we have to take the poles on this real axis. We should not consider this imaginary axis. So here if we observe, the poles are only on real axis. So we have to take the sum. Now I will take here sum. So what are the poles? That is minus 2, minus 3, minus 4. So I will take here sum minus 2 plus minus 3. That means minus 3, minus 4. So this is sum of real part of pole minus sum of real part of 0. So real part of 0 is minus 1. So we have to take this minus 1 inside the bracket divided by number of poles minus number of zeros. Number of poles 3 minus 1, that is 2. Now we have to calculate this. So 4 minus 2, that is minus 6, and minus 3, that is here minus 9 plus 1. Now if we observe this minus will become plus. So minus 9 plus 1, that is minus 8 divided by 2, that is equal to minus 4. So this is the centroid, that is the point of intersection of asymptote on real axis. So here is the minus 4. So I will say that this point is nothing but sigma A. Now at this point we have to take the angle 90 degree and 270 degree, and we will draw the asymptote. So for that we will use this, and this is the real axis. So from this axis we have to take the angle starting from this. Now I will take the center at minus 4, and here from this 0 to 90 degree we will mark here one point. Then again we have to take the angle of 270 degree, that is 180 plus 90. So again I will take here the angle, that is 270, and we will draw the asymptote. So at these angles, and point of intersection is nothing but minus 4. So passing from this minus 4 we have to complete this line. Now one important thing, I will show here the angle. So here this angle is 90 degree, and this angle, so I will show here, and this total angle. So we have to start from this line, and this total angle covered is 270 degree. So these angles are important. So this is the line. So these two are the separate lines. This is the line that is at 90 degree, and this is the line that is at 270 degree. Now we will move for the next step, that is calculation of breakaway point. So why to calculate the breakaway point? Now if we observe this, we know that the points in between minus 3 and minus 4 are the part of root locus. And we also know that there are two branches that terminate to infinity, and we have to draw these two branches parallel to the asymptote. So this is one asymptote and this is second asymptote. Now how to select that particular point from which branches depart on the real axis? So how we can define this breakaway point? So breakaway point, it is the location on real axis from which branches depart, and it is the solution of dk by ds is equal to 0. Now we have to select the point on the real axis from which we have to start the branch, and that will terminate to infinity along this asymptote. So we have to calculate the solution for dk by ds is equal to 0. So how to calculate this? Now if we know that this is the open loop transfer function g of s into h of s. So from this transfer function we have to write the characteristic equation. So characteristic equation is 1 plus g of s into h of s. So I will write here 1 plus k s plus 1 divided by s plus 2, s plus 3, s plus 4. So this is the characteristic equation. Now from this characteristic equation we have to take the value of k. Now how to take the value of k? So for that I will transfer this plus 1, that is this 1 is getting added to this. So I will transfer this 1 to the other side. So it will become minus 1. And then what is happening? Minus 1 is equal to k s plus 1 divided by s plus 2, s plus 3, s plus 4. Now again I will transfer this denominator to the other side. So it will move to the numerator. So minus 1 multiplied by s plus 2, s plus 3, s plus 4, and this numerator will move to the denominator. So what is the value? K is equal to, this is the value. So in this way we have to take the value of k. Now we will simplify this because we have to take the solution for dk by ds is equal to 0. Now I will multiply here. So minus sign we will take as it is, and then s plus 2 and s plus 3. We will multiply these two brackets, that is s square plus 2s plus 3s, that is equal to 5s plus 3 multiplied by 2, that is 6. Now in the second bracket, s plus 4 divided by s plus 1. Now again we will multiply with these two brackets. So minus sign will remain as it is. So I will take s cube plus s into 5s, that is 5s square plus 6s plus 4s square plus here 5 into 4, that is 20s plus 24 divided by s plus 1. Now again we will simplify this. So here minus s cube plus 5 square plus 4 square, that is 9 square plus 26s plus 24 divided by s plus 1. So this is the value of k. Now we have to differentiate this k with respect to s. So for that, this is the equation in numerator and denominator. So I will take minus sign outside. Then how to take the differentiation? So we know that the denominator constant we have to take, or we have to differentiate for numerator. So I will take the first step, that is denominator constant into, we have to differentiate with this numerator, that is s cube, that is 3s square plus 2s, so 9 multiplied by 2, 18s plus 26, minus numerator constant we have to take the, or we have to differentiate this denominator. So we have to take the numerator as it is, that is s cube plus 9s square plus 26s plus 20. And how we can differentiate? So there is only one s term, so it is equal to 1. So I will complete the bracket, and we have to take the minus sign outside the bracket, divided by, we have to take the denominator square, that is s plus 1 bracket square. So this is the formation, or in this we have to apply this rule, that is we have to take denominator constant, we have to differentiate numerator, minus numerator constant we have to differentiate denominator, divided by denominator square. So this is the rule that we have to apply when there is the s term in numerator and denominator also. Now again we have to simplify this. So I will take this minus sign outside the bracket. So I will multiply this s plus 1 inside the bracket. So 3s square into s, that is 3s cube plus 18s square plus 26s plus, again we will multiply with this one, that is 1 into 3s square, that is 3s square plus 18s plus 26. Now I will multiply this minus sign inside. So here minus s cube minus 9s square minus 26s minus 24. So this bracket is getting completed, divided by s plus 1 bracket square. Now again we can easily simplify this. So if we observe here, I will take minus sign outside the bracket. 3s cube minus s cube, that is 3 minus 1, 2s cube, we have to take the bracket. Then 18s square plus 3s square minus 9s square. So if we observe here, s square term is 1, 2 and 3. Now 18 plus 3 minus 9. Now if we observe here, that is we have to take plus 12s square plus 26 plus 18 minus 26. So this 26 is getting cancelled, plus 18 is. Then we have to take this constant term, that is minus 24. So here plus 26 and minus 24, that is plus 2. So this is the simplified form, divided by s plus 1 bracket square. Now again, if we observe, we can simplify this. So how to simplify this? That is, we have to divide it by 2. But before that, for the calculation of breakaway point, we have to take the solution of dk by ds is equal to 0. So we will equate this term that is equal to 0. Now if I transfer this denominator to the left hand side, then it will become 0. I will transfer this minus sign to the left hand side, then again it will become 0. So again, and we will simplify this at the same time. That is, I will divide this whole term by 2. That is s cube plus 6s square plus 9s plus 1, which is equal to 0. So this is the solution. Now we will find out the roots for this equation. So this is the higher order equation. So how to find out the roots? To find out the roots for this equation, we will use here the trial and error method. So how to apply this method? So first we will write the coefficients one by one. That is, for this s cube there is coefficient 1, then there is coefficient 6, 9 and 1. Now we will mark here one line. Now approximately, suppose I take here minus 1. Then first number we have to take 0. So 1 plus 0, that is 1. So 1 multiplied by minus 1, that is minus 1. So 6 minus 1, that is 5. So 5 multiplied by minus 1, that is minus 5. So we have to take here. So 9 minus 5, that is 4. And 4 multiplied by minus 1, that is 4 minus 4. So if I take here minus 4, then minus 4 plus 1, that is minus 3. But here the required value is 0. So how to take 0? So for that we have to change the number. Now here minus 4 plus 1, that is minus 3. So this is much larger. So we have to take the small number. Now I will take here minus 0.12. So if I take minus 0.12, then again we will try. So first number we have to take 0 here. So 1 plus 0, that is 1. Now I will multiply this 1 minus 0.12, that is minus 0.12. So minus 0.12. So 6 minus 0.12, that is 5.88. Then again 5.88 multiplied by minus 0.12. So if we multiply this, we will get the answer, that is minus 0.71. Then 9 minus 0.71. So 9 minus 0.71, that is 8.29. So this 8.29 multiplied by minus 0.12. So 8.29 multiplied by minus 0.12, that is equal to minus 0.99. But this 0.99 is equal to 1. So we have to take here as a minus 1. So this 1 minus 1, that is 0. So here is the required answer, that is 0. So when here is 0, then we have to select these 3 numbers. So from these 3 numbers we will write the equation. That is, we can say that the one of the root is minus 0.12. So I will write here, that is s is equal to minus 0.12, because when we take this minus 0.12, then here the required value, that is 0, is there. Now from these remaining numbers we will write the equation. So how to take? Now we have to take the remaining, that is for this s cube we have to take one number less, that is 1s square plus 5.88s plus 8.29. Now I will write here, therefore equation is s square plus 5.88s plus 8.29 is equal to 0. So this is the equation. Now again we have to find out the roots. So how to find out the roots? So for that we have one formula. So formula I will write here, that is minus b plus minus under root of b square minus 4ac divided by 2a. Now what is this a, b, c? So here coefficient of a square is 1, that is a. Then coefficient of s is 5.88, that is b, and this 8.29 is nothing but c. Now again we will put this value. So minus b, that is minus 5.88 plus minus under root of b square, that is 5.88 square minus 4ac. So 4 multiplied by a is 1. So 4 multiplied by 8.29 divided by 2a. So only we have to take 2 because a is equal to 1. Now we have to solve this and then we will get the other two roots. Now next step is solution, that is 5.88 plus minus 34.57, that is we have to take square root 34.57 minus 33.16 divided by 2. So when we solve this square root, we will get here minus 5.88 plus minus under root of 1.41 divided by 2. So I will take here 1.2. So minus 5.88 plus minus 1.2 divided by 2. So we will split this. We will take first minus 5.88 plus 1.2 divided by 2. And then we will take minus 5.88 minus 1.2 divided by 2. So if we solve this separately, then here answer is minus 4.68 divided by 2, that is equal to minus 2.34. So this is one of the root. And then next when we solve this, we will get minus 7.08 by 2, that is s is equal to minus 3.54. So if we observe, these are the three roots. So now we have to find out the point on the real axis for which the breakaway point is there. So how to select the breakaway point? Breakaway point is the point in between, one of the point in between these 3 points. Now if we will check the first number, minus 0.12. Now if we observe, we know which points lies on the, which points are the part of root locus on real axis. So all these points are on real axis. So minus 0.12, so point is here. So on the right hand side there is no any odd number of poles and zeros, so this point is getting cancelled. Now we will check the second point, that is minus 2.34. Now minus 2.34, that means point is here. Now if I check, the sum of real part of poles and zeros should be odd number on the right hand side. So if I select these points, so on the right hand side there is sum of poles and zeros is 2, that is even number, and that is not the odd number. So this point is not the part of root locus, so this point is also getting cancelled. Now next point is minus 3.54. Now if we observe here, 3.54 is in between minus 3 and minus 4. If I check this, on the right hand side the sum of poles and zeros 1, 2, 3, that is the odd number. So this is the part of root locus. So this point is the part of root locus and we will select this point as the breakaway point. So I will write here, that is this point is minus 3.54 and this is the breakaway point. So we have to show this. This is breakaway point. Now how we can say that? Now from this breakaway points the branches depart. So branches depart in which way? That is parallel. We have to draw the that is the direction along this asymptote. So asymptote is the vertical line, that is vertically upward and vertically downward. So how to show that? That is the branches are getting departed, that is the branches are originated from this point on the real axis, because all the points in between minus 3 and minus 4 are the real part of root locus. So I will show here. It will move to the infinity. So this is the second branch. So we have to show, this is first branch that we have already shown. This is the second branch, and now from this minus 3 again we have to show the third branch. So this is also, this will move to the infinity. So this is the third branch. So all these 3 branches are shown and the root locus is drawn.